So good morning, good afternoon, everyone, and welcome to this webinar of WFEO. For those who do not know me, I'm Marilyn Vaiani, and I'm the Secretary General of the World Energy Council France. And I also have the honor of chairing the Energy Committee of the World Federation of Engineering Organization. For those who may not yet be familiar with the World Federation of Engineering Organization, it is a global and non-governmental organization that represents the engineering profession worldwide. Established under the auspices of UNESCO, it brings together a network of 30 million engineers across more than 100 countries. WFEO operates through a specialist committee and working group, including the Committee on Energy. And as a WFEO and as energy engineers and scientists, we consider that we share a responsibility for identifying and implementing the most effective technology for energy transition. And also we strongly believe that international cooperation and sharing of knowledge are key to achieve SDG 7, affordable and clean energy for all. And this is clearly the guiding principle of our work within the Energy Committee. We have launched in that context in 2025 a webinar series. And maybe Chloe, you can present it. Thank you. Who started with the electrification access gap and the policy recommendation. We also shift our focus after that to understand why nuclear power is making a comeback with a representative from the International Atomic Energy Agency. After that, we switched to solar PV with the chair of the task group Solar of WFEO to explore the topic of PV module recycling as a necessity for future PV development. And we share presentation from different regions of the world. And the last, our last webinar was on IA for power system with Dr. Weishen Yang from the Department of Intelligence Artificial at China Electric Power Research. And today we have the pleasure to skip to a more global presentation. 10 years after COP21 and the Paris Agreement, we really find interesting to have a global overview of energy trends with Quentin Bchini from Enerdata. Just a reminder, you may ask your question at the end in the chat. Quentin, it is my pleasure to give you the floor now to present your vision of the global energy trend. Thank you very much.
Thank you, Marilyn. I will share my slides and hopefully you will be able to see them. All right, so you should be able to see my slides. So thank you very much, first of all, for attending this webinar. I'm very happy to present a work that we've done actually earlier this year on basically looking, like the core of the work is looking at the consolidated figures for energy consumption in the G20 countries and to try to, position these recent trends versus what we've seen historically, and also to try to better understand what this means in comparison to our commitments or climate-related commitments, and especially 10 years, as Marilyn pointed out, 10 years after the COP21 in Paris and the Paris Agreement. So let's get into it. First, a few words on Enerdata. So we are a relatively small and independent energy research and consulting company founded in 1991. We are basically experts in, looking at energy balances and or forecasting, mostly projecting energy balances on a global level. We are based in Grenoble, which is a small city in France, in the French Alps, but we also have a subsidiary in Singapore. And we have a global reach with clients all over the world and partners all over the world. Our activities are basically like, this is a way of representing what we do. A lot of data analysis, data science to feed into data processes and data sets that we provide to clients. energy system modeling, so global energy system modeling, power system modeling, to try and better understand what are the relationships between like the different variables at play in the energy system, and try to project the future of these energy systems. An overall expertise and understanding of how these systems operate, how markets are operating as well. Market intelligence also, try to understand what is at stake and what are the news basically, and the changes that we can observe in energy markets. So without further ado, let me start my presentation. So as I was saying, the idea is to just give you a very top level representation of what happened basically in 2024 in terms of energy consumption in the G20, but looking at different regions and countries within the G20. We'll have a focus more specifically on the different energies and not just total consumption. Emissions as well, CO2 emissions as well. Then we'll look at what has been going on versus what should have been going on if we were to be in line with the commitments that we had, especially back in 2015 during COP21. And we'll have a focus on more specifically looking at the different sectors in what happened in the European Union. So a first overview of like the key energy and climate figures for 2024 shows that we've had like a 3% economic growth. So basically, after the COVID pandemic, there's been obviously a decrease in growth, and we've had a rebound for the years after that, and we are back to the historical trend in terms of economic growth, with approximately 3% growth overall in G20. Obviously, the trends are very different depending on the regions we're looking at. I'm not going to focus too much on economic growth, obviously, but this is one of the key activity indicator that is to be taken into account when looking at the evolution of energy consumption. Energy consumption, looking at primary energy consumption, has increased by 2%, which is slightly lower than 2023, but it's higher than the trend observed in the last decade. CO2 emissions have also increased, but only by 1%, which is in line with what we've been observing in the 2010s, basically on average. This is yearly average, the figures that are reported here, yeah. And a bit lower than what we've seen in 2023. So we're looking below at the bottom at energy intensity. Well, it's final energy intensity. Primary energy intensity is also something that we could have presented. Basically, the problem with primary energy intensity is that it's because of the conventions on how to integrate, especially renewables and thermal energy. It sort of biases the historical evolution. Basically, the more renewables you have in the mix, in the primary mix, the lower the energy intensity, because it's considered that basically the efficiency of primary electricity is 1, whereas the efficiency of coal, for example, is obviously lower. So here we're looking at final energy intensity to sort of avoid this bias. It's been very slowly decreasing, and obviously, if you look at the 2010s, it was on average -2% per year. Now we're only at barely, like, not even -1%. And the CO2 factor is basically the ratio of emissions on energy consumption. So the energy intensity is energy consumption on GDP. The carbon factor is CO2 emissions on energy consumption. Similarly, it hasn't really been decreasing that much, but that was already the case prior, but it hasn't been any changes. So these two indicators are basically proxies for energy efficiency and for final energy intensity, and the carbon factor is a proxy for the level of decarbonization that we're observing in the global, in the G20, in this case, energy system. So now looking at, so I will present this particular chart because it's like the template that we use for across this presentation. So basically what you have here, it's primary energy consumption, and it's the so the growth or decrease, like the evolution in percentage every year. So the orange bar is for 2024, the previous year 2023 in blue, and the average for the 2010s, basically between 2010 and 2019, just to see the comparative evolution, is this well, green dot here. So you can see, like, for primary energy consumption, it has increased by 2% in 2024. It's slightly higher than what we've seen in the last decade. It's slightly lower than what we've seen in 2023 for the G20. But you can very clearly see here that the dynamics are completely different. Whereas if you look at the OECD, so developed economies within the G20, it had decreased. Primary energy consumption had decreased in 2023. There's a little bit of a rebound, but it's very small. And this is in line with what we've seen historically, right? So the primary energy consumption is not increasing so much. But in emerging economies, on the contrary, the percentages are much higher. And now actually the non-OECD represents 60% of the total energy consumption in the G20. Even within developed economies, we see slightly different trends. For example, in the EU, which has been obviously more affected by the energy crisis, there was a huge drop in primary energy consumption in 2023. Now it's been a very slow decrease in 2024, whereas the US has been not as affected by what happened since 2022. Looking at CO2 emission, which is obviously a direct result of the evolution of energy consumption, but also the evolution of the carbon factor, right? The carbon content of the energy consumption. It has only increased by 1%, which is a better figure, a better results than what we've seen historically, but still an increase. And again, as expected, different dynamics depending on if you look at emerging non-OECD economies and OECD economies. So a decrease in CO2 emissions in developed economies. You can see a very sharp decrease that sort of mirrors what we've seen in energy consumption, obviously, and an increase in emerging economies. But the increase is slightly lower than what we've seen for energy consumption, meaning there has been some decarbonization. So CO2 emissions do not increase at the same rate as energy consumption, but they still do increase. There's no real decoupling at the moment. And this is what we see here. The carbon factor is, well, not decreasing is not completely true, but it's very slowly decreasing. So this is the carbon factor. For the G20, it's below 1% per year, both historically in 2023 and in 2024, it's slightly improved, but it's still very low. Obviously, this is so the observation here again is that it decreases at a higher rate, but still not a very impressive rate, especially if you look at 2024. It was not so much the case in 2023, where it was almost minus 3%. And now it's a little bit more than 1% decrease of the carbon factor in developed economies. For non-OECD countries, the carbon factor is even increased. So this is mostly due to structural effects between countries. We'll get to that, I think, when looking at the evolution of the different energies. And it has very slightly decreased in 2024. This is mostly driven by China. So the key takeaways when looking at these very top-level figures, right, is that we are back to basically the same level of growth economically. So if we use that as a proxy for activity, we are back to the same as we're basically in a comparable situation. So that makes the comparison of the other indicators a little bit more robust. Energy consumption continues to rise, and it's even faster if you only look at 24 as the as the pace that we observed before COVID, basically in the 2010s. So we are far from the decoupling that we want to observe between energy consumption and GDP. So same economic growth, higher energy consumption. So the energy intensity, but this is a result from that. The energy intensity is not going in the right direction, right? And thus is very far from being compatible to a 2 degree or below 2 degree trajectory. Obviously, the trends are very different, and there are a lot of structural effects behind that. There has been an increase in CO2 emissions, although it has been at a slower rate. We start seeing a decrease in the carbon factor. This is, and we'll see that in the next slides, but this is due in large part to renewables in electricity generation. But still, this is not compatible with what we would like to observe in long-term trajectories. So now we're going to look a little bit more deeper into the role of like the different energy carriers. So 2% increase in energy consumption, we've seen that. And if you look at the different energies, we're looking at a primary consumption of coal, oil, gas, and final consumption of electricity. So coal has increased by 2%. This is a little bit lower than 2023. This is much higher than what we've seen in the 2010s, which is very worrying looking at coal. For oil, it's actually a very small, barely significant, but still a decrease, and it's a shift in trends compared to what we've seen so far. Gas has recovered. We'll look into that more specifically, but obviously there was an energy crisis in Europe that affected the price of gas, and actually this was pretty much spread, and it was an international concern. Now gas prices are still high, but they have decreased a little bit, and gas consumption has increased quite significantly in 2024. Electricity, and we'll look into that in more detail, but electricity is picking up. Basically, electricity is increasing in volume, plus 4% compared to plus 2.5% in 2023, which was a rate similar to what we'd seen prior to that. So coal. So you have a similar chart here looking at like the percentage evolution of coal consumption across the G20. And on the top right, you can see the evolution of the share of coal in total primary consumption. So we look into both. So as said, coal consumption in absolute terms continues to increase. This is mostly driven by China, India, and also Indonesia, who's obviously a player with a very important rate of development, right? So even though it doesn't, the percentages, and I forgot to mention that, represent the share in the total G20 consumption. So obviously the dynamic for Indonesia is very impressive, like plus 10% of consumption for coal in 2024, but Indonesia only accounts for 4% of total coal consumption in G20. Whereas obviously the consumption, the evolution was more moderate in China and India, but they represent a much higher share of the total. And it's been obviously decreasing in OECD countries quite significantly with a lot of coal phase-out policies, especially in power generation. But it only accounts for 14% of the total, so it hasn't really been that important when looking at G20 overall. If you look at the share of coal in primary consumption, you can see that, so it has increased in absolute terms. It hasn't really decreased in relative terms either, which is maybe even more worrying, is that there's no real shift away from coal in the G20, and that is mostly driven by emerging economies, China, India, Indonesia, as we've said. Whereas in OECD countries, you can see that there's been a decline, maybe not as sharp as we would like, but still a decline from 20%, relatively stable, all the way from 2000 to 2015. And well, from 2015, we can see that it has declined to represent around a little bit more than 10% of the primary mix. Oil consumption, So it has decreased, as we've said. There's been a rebound basically in 2023, but it's very much biased by China. If you look at more like long-term evolution, we have, well, I mean, it has increased in China as well if you compare to a pre-COVID consumption, and it's now back to a pre-COVID level, actually, looking at the G20 consumption of oil products. But in China, there was a lockdown basically in 2022, and therefore a huge rebound in oil consumption in 2023. So this sort of biases the analysis here. Overall, oil consumption, whether it's in absolute terms or in relative terms, is on a slow organic decline due to the increase in EVs, even though it's not significant at the moment, and this is why the decrease in the share of coal is also not very significant, and other elements as well. As we've said, there's been a rebound in gas consumption. This is following, obviously, a crisis and very high prices, which has led to a huge decrease in consumption, especially in the EU, but in other countries as well, in Japan, for example. So there's been a rebound because of that. There's also generally more and more fuel switching, especially in the power sector, from coal to natural gas. That explains why there's a trend of, I mean, if you exclude these temporary shocks that we've observed, especially in Europe, there's this long-term trend of switching gradually to natural gas in a lot of sectors, and this is what we are basically seeing. Now, looking at electricity, to me, this is a bit contrasted. So obviously it increases a lot. So you see the rates are much higher than what we've seen so far. Electricity increases pretty much everywhere in absolute terms. You can see that in the US and in the EU, but this mostly reflects a reduction in energy consumption as a whole. You can see that there was a decrease in 2023, now a rebound in 2024, but the rates are much lower than what we see in non-OECD countries. If you look at the charts on the top right, you can see that the share of electricity in final energy consumption is increasing pretty much everywhere, but not to a very impressive extent, let's say. If you look at the average for the G20, we were here like between 15, so around 17, 18% in 2000, and up to a little bit more than 20% in 2024. This is driven, by the way, by not only the dynamic was much more impressive in China, but also obviously China accounts for a large share of the energy and the electricity consumption as a whole. So basically, electricity, which is obviously a pillar, a very important lever in energy transition pathways, is not really increasing that much so far. And also because, I mean, you would expect an electrification of energy users, which is not really happening to a large extent. You also have new energy users, such as data centers, which do not account for a huge part of the energy consumption so far, but it's going to be a driver increasing electricity consumption. But this is basically new consumption, right? It's not replacing fossil fuels. Now we'll look at the power mix. And so power generation is an area where we see a lot of improvements, especially looking at the increase in the share of renewable in power generation, reaching 30% of the power mix, and especially driven by solar and wind, and mostly more solar than wind recently. But fossil fuels still represent around two-thirds, and this has not really decreased at a very significant rate in the latest year. So there's still a lot of basically fossil-fired power generation globally in the G20, despite these emerging, despite the fact that renewables are emerging. If we look more specifically at wind and solar, so looking at wind, obviously the installed capacity have increased quite a lot, so plus 105 gigawatts in 2024, plus 11% compared to 2023, which was already quite impressive. No, actually, this is not. No, this seems counterintuitive. Okay, there's something wrong with the figures because it says plus 11%. Okay, I'm not exactly sure. I think we should refer to the chat, right? So the figures are quite impressive. It's slightly lower in 2024 compared to 2023. But what we see is that it's mostly driven by China, which accounts for 76% of the new installed capacity. Generation obviously has also increased by 8% in 2024. Again, mostly driven by China, which accounts for 40% of the total wind generation. And the last 60% is basically 20% in the EU, 20% in the US, and the rest of the G20 countries account for the remaining 20%. Looking at solar, it's even more impressive, actually a lot more impressive. We have reached like 406 gigawatts of new installed capacity, which again come mostly like 70% come from China. Also impressive figures, but obviously they are a bit dwarfed by what happens in China, but in the EU and the US. India also has had plus 25 gigawatts of solar installed in 2024. This meant that power generation from solar increased by 29% in 2024. Yeah, and China accounts for 44% of the total generation, which is as much as the EU, the US, India, and Japan put together. So now that we've seen these past figures, looking at 2024 and how it compares to previous year, we'll try to make a comparison with basically what happened compared to what we should have seen happening. This is something that I mentioned in the intro, looking at using our own long-term energy scenarios. I'm sure you're familiar with the World Energy Outlook from the IEA. We basically do a similar exercise every year that we call Enerfuture. So 3 energy and climate scenarios running up to 2050 that give us basically a range of the different evolution of the global energy system using a model that is called the Poles Enerdata model, which covers the entirety of the global energy system. Basically, the 3 scenarios that we're looking at are basically Enerbase being a baseline scenario, right? A continuation of what we've seen historically in terms of policies, of trends, and this leads to around plus 3% in terms of temperature. Then there's the Enerblue scenario, which is basically a scenario that is aligned with the countries basically achieving their NDCs. And the temperature, the related temperature increase would be between 2 degrees and 2.5 degrees in this case. And then we have a more ambitious, more backcasted scenario, which is in line with the Paris Agreement of staying below 2 degrees, well below 2 degrees Celsius in terms of temperature increase. If we look at the picture in terms of actual figures, taking these 3 indicators, basically the evolution of CO2 emission from combustion in G20 countries, the evolution of primary energy demand, and the share of fossil fuels, we have first just an extrapolation of what we've seen since 2015, looking at what basically we've been observing since the COP21 in the Paris Agreement, and just extrapolating that all the way up to 2035, just to see, if we were to do the exact same thing, what would happen. And then you have 2 of our scenarios, namely Enerblue and Energreen. What is interesting here is that you have a difference between the 2 scenarios, right? They are different in terms of construction, obviously, but Enerblue is an NDC aligned scenario, Energreen is a well below 2 degree scenario. So the first observation that you can make is that the 2 are not similar. So the NDC, even if we assume that they are achieved and the commitments are fulfilled, it's not going to be enough to reach the overall underlying objective of the Paris Agreement. But what we see mostly here is that this suggests a huge disruption and a huge shift in trends if we are to be aligned with our objectives compared to what we've been doing so far, basically. And if we go back a few years, because we've been doing this Ener Future work for quite some time now, I actually retrieved the data from previous scenarios, starting in Green 2016, starting with Green 2016 here, which basically, so the scenario that we produced right after the COP in Paris, right? So you can see that over the years with Green 2016, Green 2022, 2024, and Green, the latest basically Green here, you can see that every year basically the slope is getting steeper, right? We keep having, even the COVID effects as not, we would need a COVID basically every year if we were to catch up with the pathway that we need to be on, basically. And every year it's getting more unrealistic that we'll be able to catch up with this trajectory. So in 2016, it seems relatively easy and not that impressive, the shift that was needed, but every year it becomes more and more difficult. We would need, basically, if we were to catch up with this trajectory, we would need a 5% per year drop, which is what I was saying, is it's as if we had like the impact of a COVID pandemic every year. But more than that, it's not just about trajectory. We have basically cumulated emissions that we have emitted, right, ever since 2016 that we now need to catch up. So it would have been much easier to follow this path when we were in 2016, and now we need to do extra effort after 2030 if we want to achieve our climate targets. Now I'm trying to go a little bit further into the analysis, if you can allow me to have a sip of water. Basically, looking at specific indicators that are often used to characterize long-term energy scenarios. So looking at the energy intensity, so we're now familiar with this concept. So the ratio of energy consumption on GDP, the carbon factor, the share of electricity in final consumption, and the share of renewables in electricity generation as a good proxy for the decarbonization of electricity generation. And this is basically the percentage per year. So in gray, this is the percentage per year that we observed between 2015 and 2024. In blue and green, it's respectively what we would need to see from 2023 to 2050 to be in line with basically the respective objectives of the scenarios Ener Blue and Ener Green. So looking at just the difference in scale between what we've seen and what we would need to see for these different indicators. So energy intensity has improved a little bit, decreased a little bit, but not to the extent that we want in our scenarios. Carbon factor has barely decreased in the last 10 years. And obviously it should be much more the case in the future. Electricity, as we've seen, has also not really improved. Like the share of electricity in final consumption has not really progressed on the G20 level, and it needs to pick up quite substantially. Renewables is maybe one indicator where we've seen some improvement, but it's still very far from what we would like to see in our scenarios, basically. So not enough has been done, not enough is happening. And we need to pick up on all fronts, basically, is what we're observing here. So to conclude on this, so energy consumption is growing at a faster rate than before the energy crisis. This is really concerning, especially if you look at coal consumption. This is very troubling. There is basically no decoupling between GDP and energy consumption. It's actually getting worse, right? Is what we've seen, and there's also no real significant changes in the carbon content of energy consumption. The carbon factor is not decreasing either. There's no decoupling between energy consumption and CO2 emissions. Each year passing takes us further away from a pathway that is compatible with the objectives of the Paris Agreement. The dynamics are actually different in different regions. So obviously, emissions, energy consumption is driven by activity, demographic, economic activity in emerging countries. And obviously, this is not so much the case in developed economies. But in terms of relative indicators, there's no huge shift. It's a little bit better in developed economies, but not really substantially. Renewables are expanding at a rate that is impressive, but not sufficient so far. And the problem, and I think we'll get into that when looking also at the case of the European Union, the problem is that even if renewables are increasing electricity, because the goal is to decarbonize electricity and to expand the scope of electricity by electrifying key energy end users, but this electrification is not happening. So even if you decarbonize electricity generation, the impact is limited. And as we've said, the consumption of fossil fuels, and especially coal, continues to grow in volume and barely decrease in share. So this is now the last section. I'll try to go through it relatively quickly. This is a specific focus looking at different sectors on the European Union. So if we look at CO2 emissions in the EU 27, since 2015, we see that the emissions are down by 2% per year. And we need to go a little bit beyond that to understand why. The first thing that we can see is that, like, if you look at the structure of the CO2 emissions by sector, and this sort of echoes what we've been saying so far, this is mostly driven by the power sector, right? So the power sector has been decarbonizing at a much higher level than the other sectors. In final consumption, emissions are down only by 1% per year. We have to, and we'll look at the different sectors and how it affected the different sectors, but this is in a context of, again, low economic and demographic growth. So before, you know, self-congratulating, we need to really understand what is going on here. If we look at industry in particular, industrial activity has declined in the EU by 5%. So this is the average activity index for manufacturing industry. If we look at specifically sectors that are very high in terms of energy intensity, the decrease is even more important. So we see here basically iron and steel, metallurgy, chemicals, non-metallic minerals especially have been affected, and non-metallic minerals basically cement, concrete, also glass, ceramics, but mostly cement. It has decreased by 7% since 2022. And this actually explains most of the reduction that we see in the industry sector in the European Union. So there hasn't been really, electricity consumption has decreased actually overall, and the share of electricity in total energy consumption has marginally increased. And again, this is mostly due to structural effects, right? Because the share of highly intensive, basically, industry branches have gone down compared to other branches, which is usually basically, well, for example, high temperature that is needed. So energy consumption that is mostly from fossil fuels that is not really electrified yet. So because their relative share has decreased, this meant that the share of sectors that are not relying too much on fossil fuels has increased by construction, which means that the share of electricity consumption being slightly higher is not really reflective of switching to electricity, but rather just structural effects. So basically no real, I mean, this is really, this is maybe a bit too harsh, but not a lot of structural gains in terms of decarbonization, energy efficiency, and mostly, unfortunately, decreasing activity. If we look at households, this is between 2019, because I think it was an interesting year, especially in terms of climate effect. And this was before COVID mostly. So looking at 2019, this is like a waterfall graph basically showing the emissions from households in 2019 and the emissions in 2024. And we actually broke down this evolution between different drivers. The first being basically activity, which is, well, it could mean a lot of things depending on the actual energy use. It's the increase in population, surfaces, household equipment, etc. So all of the things being equal, activity has increased. So therefore, this should have increased energy consumption and therefore emissions. Now, if you look at the different drivers that have allowed to compensate for that, to more than compensate for that, you see the role of heat pumps, which is real, but not very significant. A lot of technical savings, so increase in efficiency of the different equipment. Fuel switching, meaning from I don't know, oil, for example, in heating towards electricity or natural gas and that sort of things. A climate effect, meaning a lower need for heating because of a lower a temperature overall. This is something that's a higher temperature overall. This is something that we'll see in long-term scenarios as well. At least it's to be expected. So this increase in temperature is going to reduce the need for heating. And then we have what we call other here is basically a residual component that we assimilate to behavior, right? But these behaviors could have meant lowering the energy consumption for heating or other uses, most likely, especially in the EU, as a reaction to high prices. Electricity barely increased, only gained 1.5 percentage points since 2019. This is something to be observed as well. There's no real electrification in households either. Heat pumps have been emerging, but they do not represent a really high share of equipment. Also the downside. If you look at it from an energy balance perspective, you're switching to electricity, but there are huge energy efficiency gains that sort of offset the increase in electricity consumption in absolute terms. I'll try to go quickly through the last slides, but we're near the end here. CO2 emissions from transport in the EU actually been relatively stable since 2022. And they're actually lower than in 2019, so pre-COVID. Basically, what we see is that passenger traffic has not really recovered its pre-COVID level. If you look at freight goods traffic, it's relatively stable, but passenger traffic is a little bit lower than it used to be. So this explains why CO2 emissions have been lower and not electrification. The share of oil products in transport sector as a whole is basically stable. It's not decreasing. It's around 92%. So we're not really seeing any modal shifts. Road transport accounts for 90% of passenger transport and 80% of goods transport. So this is 90% being relatively stable. And there's actually a moderate increase in goods transport. So basically, there's no real electrification. And I'll further explain that afterwards. And there's no modal shifts. What we see is mostly traffic that hasn't really recovered its level after COVID. Why I'm saying that there's no electrification when it's quite noticeable that there's been a dynamic of having more electric vehicles. What we need to understand is, despite the trend here, and if you look at the orange line and the blue line, so the orange line is basically the share of electric vehicles in new cars, passenger light vehicles, basically. And the blue is the stock. So it's quite impressive, the increase that we've seen in new cars. Note that it started decreasing actually in 2024, but it still represents only 2% of the overall car stock, which itself is only a fraction of energy consumption in transport. Electricity represents only 2% of total energy consumption from transport, and it's still actually, the majority of it's still in rail transport and not in EVs. In road EVs. Now, finally, looking at the power sector, and I'll be, I think, relatively quick. We do see a huge role of renewables and a huge decarbonization of power generation. This is a breakdown between, again, the different drivers of emissions from power generation reducing, and it's actually mostly because of a substitution to not just renewables, by the way, also nuclear, even though it hasn't really changed so much in the right direction between 2019 and 2024. It's theoretically included in this. So basically, we've been able to decrease the carbon factor between 2015 and 2024 by 40%. So that's quite significant. But again, this is limited in its impact on the overall emissions because there's no electrification of end users. So we have basically we've basically seen a very I don't know, but a really satisfying trend in terms of decarbonization of electricity generation in Europe, but we haven't seen electrification of end users. So this is limited in terms of impact on the overall emissions in the EU. So to summarize all of this, so there has been a decrease in emissions in the EU, but when you break it down, it's mostly due to the economic and demographic context. So we've seen a loss of, in terms of industrial activity, and this mostly explains what we've seen. There's still low emission and energy efficient technologies that are emerging, but the pace is not high enough, and it's still very niche applications. So as we've seen, power generation has been decarbonized to a very significant extent, but we haven't seen enough electrification of end users for it to have an impact. EVs and heat pumps, great dynamic, very niche application so far. We've seen some small positive changes in behaviors that we may want to build upon. In households, we've seen some energy sufficiency, so reduction of energy consumption, but this actually been mostly as a response to high energy prices. So, but still there is some reactivity there. And passenger traffic has not fully recovered its pre-COVID level, as I was saying earlier. That's it for me. But I'll be happy to answer any questions that you may have.
Thank you very much, Quentin, for this presentation. A bit depressing, but it's life.
Yeah, sorry.
These are the facts, so that's why it's very interesting. You can put your question in the chat, and if it's okay, there is a first one about hydrogen. As you of course know, low carbon green hydrogen was really an important strategy for a lot of countries, especially in Europe, but not only. How do you see that happening or not today in the numbers?
I mean, I think everyone is aware that it's the outlook in terms of the role of hydrogen in long-term energy scenarios, right? Looking at the entirety of the energy system has been, yeah, compared to what we were planning, most scenarios were planning a few years back, it has been sort of I mean, the role is not seen as important right now. So basically, it has decreased. Our prospects for hydrogen has been decreasing a little bit. I think this is mostly due to some applications such as road transport and especially freight transport, where electricity has basically and because it's sort of a winner-takes-all situation here, where there's a huge need for infrastructure to support a business model, in this case, EV for freight versus hydrogen. That once like one technology sort of takes over, it very much limits the potential expansion of another technology. So I think the consensus right now is that it's going to be EVs over hydrogen for this particular application, and it's sort of, I think it's most of the reason behind the lower expectation for hydrogen in long-term energy scenarios. That being said, there's still a lot of applications where e-fuels in particular are being considered, and yeah, so I think if you look at it from the perspective of the overall energy balance, it's not as high. I still think that there's a lot of sectors where decarbonization will I mean, one of the key decarbonization option would be hydrogen based. So yeah, yeah, it has decreased, but still there's a future there for some sectors.
Thank you. There is a question about, I don't know if you can answer that, but according to what you have seen and the work you've done, which country or maybe region, if it's too difficult to enter for country, would be the reference at the best in class in terms of energy transition pathway?
Yeah, that could be controversial. I don't know I mean, we really, I think it's difficult to compare. Like, I think I've mentioned that a little bit in the analysis, but when you have emerging countries that have like high economic growth, huge like demographic pressure, you cannot really look at the same, when you look at the indicators, you have to take that into account compared to developed economies who don't have the same drivers in terms of activity, at least. So it is true that looking at certain indicators, if you look at the EU specifically, probably more has been done than in other countries. And I think there might be also a responsibility, being a developed economy, to show like like an example in terms of transition. But again, it's super, like, it really the context matters a lot in this case. So I wouldn't point the EU, and also I spent a large part of my presentation explaining that the reduction in emission is actually based on it's based on the economic context rather than actual efforts that have been significant. So yeah, I don't know. And in another example is China being really a good example of renewable expansion, but on the other hand, coal consumption continues to increase there. So I don't know. I think there's a lot of examples of decarbonization. It's mostly on renewables, but I don't think for now we have a really good template for decarbonization across the world.
Thank you. There's another question about energy efficiency. I don't know if you have more data you can share with us about energy efficiency. There is a task group within the WFEO Committee on Energy on that. The question was raised by the chair of the task group. She was asking, at least, do you know if it functions at least in Europe, for example, or other countries, if the policies are efficient or not?
So we've actually been working with the European Commission. The main issue with energy efficiency is like there's no real standardized way to measure energy efficiency on a sectoral level, on a system level, right? So you can look at applications that are more efficient than others, but looking at broadly, what is the role of energy efficiency in reducing energy consumption and reducing emissions? There is no really standardized method to do that. Energy intensity is a proxy for energy efficiency in most cases, but it's really incomplete because when you look at it from an overall perspective, there's actually a lot of structural effects. Maybe one, like if you look at the industry, for example, maybe actually the reduction in energy intensity is because production from energy intensive branches have shifted away in other countries. So therefore you see a reduction in energy consumption compared to the activity or compared to the value added of the sector, but it's not because of actual technical efficiency. So this is me just disclaiming that it's very hard to measure on a system level, but overall we see a reduction in energy intensity. There's a lot of really disruptive technologies that either start being implemented, like best available practices that start being implemented or that should be implemented in the future. The thing about energy efficiency, especially in industry, but that's also true to a lesser extent in other sectors, is that I mean, if a technology is more efficient, then it's going to be picked up. So it's only a matter of time, if you have a best available technology that allows to save energy, that it's going to be picked up. And that's generally what we see across industry. You also have the example of heat pumps in the residential sector, but then there are economic considerations there. It's not necessarily easy for everyone to invest in a new heating equipment, even if the return on investment is positive, right? And this is why measures to help funding these investments are important. So it's really hard to measure, but definitely it has played a continuous role in decreasing energy consumption overall.
Thank you. There's another question about data center and cooling. You mentioned it very briefly. Are you able to identify the growth in electricity consumption related to this usage, or it's difficult to identify it?
We have, I mean, I don't have the figures in mind. We posted something, we did an analysis of that recently. I don't have the figures in mind. Maybe I can send them afterwards. We are able to identify it. What we are not sure of is how it's going to evolve in the future. So we're looking into this and trying to produce scenarios, but there's a lot of uncertainty in terms of, you know, what applications are we talking about exactly? What will be the energy intensity of the sector overall? This is very uncertain, and it will play most likely a role, but to what exact extent we don't know yet. But it's definitely going to drive energy consumption.
Okay. You mentioned the decrease in oil consumption, very small, but a decrease. You work also on scenarios. Do you think that means we are at a peak oil in terms of consumption, or it's not really realistic to imagine that?
Well, what I can say is that peak oil is going to come from consumption and not from supply.
Yeah, I agree with you. That's exactly what one of our members told us.
That's what we finally figured out. I don't know. It's hard to say. I tend to think that at some point we'll reach the maximum level of traffic might increase in certain countries, but in the same time, what seems to be inevitable is the emergence of EVs and other electrification. There's a lot of countries where, like railways, for example, in India, have been electrifying at a very impressive extent. So I do think that there's going to be a lot of electrification, and it's going to, even if we have an increase in traffic, it's going to be compensated by that. So yeah, ultimately, oil consumption is going to reduce, and it comes mostly from the transport sector.
Okay. There's a question on coal. How do you explain the continuous growth and use of coal in some countries? Is it because there is no other energy sources available at a cheap price, or I don't know? What is your analysis on that?
Well, I mean, one really key thing that we're observing so far is that renewables, new alternative energies, renewable are increasing, but they do not substitute fossil fuels so far to a large extent. So in a country like, if you take the example of China, it's also true for Indonesia at the moment. Energy consumptions continue to increase. There's like a drive, there's a pressure that increases the need for energy, basically. And you still have coal resources, you still have power plants that you're not going to shut down just because, I mean, you know, it's going to take time. Basically, there's inertia in the processes that are already in place, in the infrastructure that you have in place. So it's increasing it could increase at a slower rate than previously, because you now progressively include alternative fuels as well. But because there's this pressure and there are resources, then I mean, there's no incentive to completely shut down coal. And actually, there's also a lot of power plants that are being commissioned in these countries. So this means that it's going to start reducing eventually, but there's still going to be coal in 2050 in China. There's power plants that are being built right now and that are being commissioned right now, and they're still going to be operating in 20 or 30 years, and it's pretty significant. So there's a shift away from coal overall, but because the drive on energy demand is high, it still means that coal is increasing. And then you have a lot of structural effects also to take into account. So from one year to another, you know, you could have, like, there's a little bit of volatility as well, especially here if you look at, you know, what happens in natural gas, especially in 2023. There's been a shift from natural gas to coal, or at least the shift to natural gas was not as important as in the previous years, because the prices for natural gas were a bit higher. So there's also a lot of like temporal economic drivers behind that.
Okay. About biogas, there is a growing need in use in Brazil, in France, and in some countries. But do you see that as a trend in other countries, in other regions of the world, or it's still too soon to see the impact of that technology?
I mean, are we talking about biogas or biofuels in general, or
maybe both? Maybe we can talk
okay,
about both.
bioenergy?
Yeah. Bioenergy, yeah.
I think because of, I mean, generally, yes, there's definitely in our scenarios as well, and I think in most scenarios, there's an increasing role for bioenergy as a whole. You also have to separate between like traditional biomass, which is often a huge part of energy consumption, especially in developing economies. So basically, there's going to be a shift from traditional biomass towards new bioenergy. There is, because of the need for resources, especially for biofuels, for example, I think there's sort of a glass ceiling basically in the expansion of bioenergy. But then again, similar to what I was saying about hydrogen, I think this doesn't mean that it's not because, you know, the expectations are not necessarily super high. It still plays a crucial role in decarbonizing certain applications, right? So I think biofuels might be limited in transport because of the emergence of electricity, but still biogas, I think, is a good application of how to decarbonize basically the gas as an energy vector. So basically as blending for the use of natural gas. I think this is a particularly relevant application, basically.
Thank you very much. And I think we are at the end of our webinar. So I really would like to thank you, Quentin, for this insightful presentation. Just to answer other comment, your presentation will be shared with our participants if it's fine for you. And you can find also more data and studies on the website of Enerdata. So this may be very useful for all of us. So thank you very much, Quentin. Thank you very much, all of you, for your participation and your questions. And see you for the next webinar in a couple of weeks. Bye.
Thank you.